All right. Good evening, everybody. So, you're welcome. You're welcome. As you join, you you recognize that you are here, so that I will know that we are here now. Okay. Good evening. Yeah, Naimeka. How are you? Okay. So let's register our presence while we wait for others to join. Happy Sunday, Naimeka. Please, I need water. Okay. So. Please, yeah, Precious, you're welcome. Can you all hear me? If you can hear me, please kindly join and tell your people to join. We are already live. Okay. Okay, so just few minutes to get the rest of us. You can share the link on your status on any other platform, whether for other departments like marketing, all other departments that do the course. You can share the link with them, let them join the class. Let me also let your president know that we have started. Okay. She told me miracle. She told me miracle. All right. Okay. As you join, all right. Okay. Precious, sir, they haven't given you what. No, this one is for today's zone. You did not bring now. I was waiting for you throughout yesterday. You did not bring any water. What will I do? Confidence, you're welcome. Ami, you're welcome. Ami, you have stressed me today. No worry. Jacinta, good evening there. How are you? You're welcome. Okay, so let's just give a little time so that please tell those people that were shouting that we should start afresh. Let them join now so that it won't be when we have gone far. Then I will be hearing, sir, you should start afresh. That will not be good, I beg. Okay. Should we start? Should we start? Let me hear your opinion. Should I start? We have 11 of you here. Yeah, Amanda, welcome. Okay. So a number of you reached out to me on WhatsApp to ask some questions, and I responded to them. Okay. And some of the questions they asked were some of the questions that I sent through your WhatsApp group yesterday. So, and particularly Amaka, she requested that we should try and finish them today, and that's exactly what I'm going to be doing. Yeah, Daniel, you're welcome. Godson, you're welcome. Chimamanda, thank you. Same to you. Happy Sunday to you also. Okay, so let's start at 45. Okay, I think that's a good idea. Okay, so we have few minutes. Please, if you have friends, you can call them, let them join, so that we don't start and they are joining late. Okay, please, let's quickly do that. Yeah, good evening. Where are my friends greeting? Okay, have I greeted Cynthia? Cynthia, good evening. Daniel, good evening. Yeah, I've greeted Daniel. Chimamanda. Um, Ami, you said yes, sir, we should please finish it today. Okay, yeah, sure, we will. Then I am fine. Cynthia, I just have small catarrh. Let me take hot water. I will be fine. Okay, who else? Precious, it's me, God, and my computer tomorrow. Of course, and God will come through for you. Okay, God will come through for you. If you just come to, anyway, I would like to meet some of you that tomorrow. Don't worry, I'll be there. You will see. I don't know. You should have seen my face from the thumbnail on this video. So if you see me tomorrow, you should be able to recognize me. If you just see me tomorrow, say hi. I will come around where you are. Ebube, yeah, good evening. Julian, Ndewo, Chidindo, sorry, good evening. Alex, I can't hear anything. Even now, Alex, check. Alex, please check. I went offline at a time. You should be able to hear me now. Okay? You should be able to hear me now. Okay. Hello? Can you people hear me? Okay. It seems that even me, I'm not hearing myself. Hello? Okay, I think I can hear myself now. Okay. All right. So, yeah. Okay, so we have 1 minute to 9:45. So we said we will start by 9:45. Many of you now disappeared. Yeah, Nna Emeka, sound check. Good evening, Antonia. Alex, okay, you can hear now. Chidinma, good evening. All right, I think I've greeted every other person here. Okay, so please, you can do well to give some reactions to the video. It helps the video. Some of your maybe emoji, laugh, love, whatever, and then also give thumbs up. I told you to give thumbs up yesterday. Some of you did not. It's not good. Okay, please, it's important. All right. So Naimeka, it seems like our suggestion is not carried. We were 16 when you suggested 9:45. Now we are 13. So maybe some people left to come back by 9:45. Okay, but this is 9:45. I think we should start. All right. So let's begin. Okay. So just a short prayer. Sorry, 7:45. Don't mind me. 7:45. Okay. Okay. Just a short prayer. Father, in Jesus' name, we thank you for an opportunity to learn. We thank you for strength. We thank you for preserving each one of us. We are grateful that you led us to service today and back home. Lord, as we prepare for our exams tomorrow, through this short revision today, we ask that you grant us grace, Lord, to be able to understand. And then tomorrow we are also able to remember so that we will write our exams and come out in flying colors. We thank you, everlasting Father. I pray that you grant each of them strength in their body, strength in their spirit, and in their mind. They have the mind of God. They are able to remember. Thank you, everlasting God. For in Jesus' mighty name we pray. Amen. Okay. All right. So let's start. Now, yesterday we were able to do let me go back to the first one we were using. I think we were using the one, of course I'll be alternating between the two of them. Okay. So I think we started with the one that has a squared all over BC. Okay, so let's go back there. And we are continuing with number 3. Remember that we stopped somewhere yesterday on binomial expansion, and I don't want to start with that. I will probably end with that. Okay, so let's follow the questions sequentially so that we are able to know our progression. All right. Okay, so let's go now. So I'm starting with number 3. So I'm starting with number 3 today, and number 3 says that we are given an nth term of a sequence. Okay, so question 3 is what we are starting with today. So we are given the nth term of a sequence, that's Tn. You know the nth term is represented with Tn. So they said is given as 2 plus 3n. Okay. And then they are asking us to find the value of S3. Okay, so what is S3? That's one of the question paper said we should find S3. And then the other question paper, so let me make it A and B. Okay, so let this one be the A, or let me clean this. Okay, so let the first one be the A. So we are looking for S3, and then let the second question type be the paper B. Okay, the question B. Okay, so and that one they said we should find where is it? They said we should find D, S3. Okay, so D, S3. So in other words, in the two of them, we are going to be looking for S3. But in the second one, we will now find D additionally. Okay, so let's begin. Where is this question coming from? This question is coming from series and sequences. Okay, so not to bother you so much, I'm just going to state a number of things that are important in this particular topic. Number 1 is let's assume we are dealing with only arithmetic sequence. Okay, so for now the nth term of an arithmetic sequence is equal to a plus n minus 1 times d, where d is the common difference. Okay, okay, all right. 24, which one is 24? Okay, the answer. All right, beautiful. Okay, so then another thing here is that common difference is equal to Tn minus Tn minus 1. That means if you pick a term, you subtract the previous term. Okay, and that will give you the common difference. I think I need to off my SIM card. People are beginning to call me. Okay, so that the distraction won't be there. Let me off this SIM. Okay, all right. Okay, so back to what I was saying. Okay, so now so what we mean here for common difference is that if you're given a sequence like, let me say 1, 3, 5, 7 and so on, your common difference is simply if you pick a term. For instance, if we pick 3, then you subtract the previous term. That's the meaning of this. If you pick 5, you subtract the previous term. Okay, so now let's now come back to the question. So the question says that Tn is given already like this. So what it means is that if I want to get the first term, which is T1, I will substitute my n as 1. So that will give me 2 plus 3 times 1, and which is equal to 5. If I want to get my T2, that will be my n will be equal to 2. So I will have 2 plus 3 times 2. and that will give me 6 plus 2, which is 8. And then for T3, I will have 2 plus 3 times 3, which is equal to, this one is 9 plus 3, 11. Okay, so you can also get your T4. So your T4 is 2 plus 3 times 4. And that is 12 plus 2, which is 14. So if you watch carefully, you will see that this is an arithmetic sequence. And the common difference, D, is simply, if you do 8 minus 5, you will get 3. If you do 11 minus 8, you will get 3. If you do 14 minus 11, you will also get 3. So your common difference is supposed to be the same. Alright, so now we have gotten the D. Now let's assume that we now want to get S3. So what is S3? S3 simply means the sum of the first 3 terms. Okay, the sum of the first 3 terms. And now what are the first 3 terms? You have the first term is 5, plus the second term 8, plus the third term 11. So if you sum these 3, you will get 24. I think that's how Alex got 24. Okay, so that's beautiful. Okay, so that means for our A, for question A, our answer is 24. And for question B, let me write B here. For question B, your answer will be D is 3. So you write 3, 24. And if you go to the options, you are going to see that the option there is option D. Okay. You say yours is very slow. Maybe your network. Or drag the red line to the end. Precious. Drag your red line to the end. Maybe that's why it's lagging behind. Sorry about that. But I think it should be okay. Okay, so this is the answer for number 3. And like you saw Alex quickly tell us the answer. That's what I expect from us tomorrow. Okay, so let's go to the next question. Okay, so the next question, which is number 4, is very important as well. So what is question 4? It says we should find 2 raised to the power of k, then plus 2 raised to the power of k minus 1 equal to 12. So I'm going to do this one while you will do the second one. Please, sir, how did you get 24? It's there now. Look at it. 5 plus 8 is 13. 13 plus 11 is 24. Now, first of all, you should know the meaning of S3. S3 means sum of the first 3 terms. And the first 3 terms, look at the first term here. Look at the second term. And this is the third term. So that's T1 plus T2 plus T3. That is your first 3 terms. So if you solve or add the 3 of them, you are going to get 24. Chiagoziem, I hope that is okay. If you have gotten my explanation, let me know. Okay, so this one you're shouting goodness, Nemeka, what happened? Is it the question? The question is very simple. Now I'm going to write the second one on the second paper, and let me shift this a little bit. Okay, so and you are going to do it by the time I am done with my own. So because they are just the same. So that one says you have 3 raised to the power of y plus 3 raised to the power of y minus 1 is equal to the same 12. Okay, so here you are looking for k. Y here you are looking for y. Okay, so let's go. All right. Okay, someone says k is 3. Beautiful. So let's look at it together. Now, what are we going to do? Of course, the options are there. Let me write the options. Okay, for the first one, A is half 1/2. Our B is 4. Our C is 3. And our D is 2. Okay, so by now, of course, I expect that you should be giving me answers the way Alex is doing, because I gave you the paper since yesterday. So you should have attempted solving it. Okay, so it's not a bad idea. Okay, so let's go. Now, in solving it, we are going to have solution. So what are we going to do there? Now, first of all, we are going to apply the law of indices to simplify this one. So we are going to have 2 raised to the power of k plus, now 2 raised to the power of k minus 1 is the same thing as 2 raised to the power of k all over 2 raised to the power of 1. Am I correct? Yes. Why? Because we are told that a raised to the power of n all over a raised to the power of m is the same thing as a raised to the power of n minus m. Okay. Okay, so that's say we don't show. No, that's okay. No, it's okay. It's okay. I must say, our accounting department is a very amazing department. In those days when I was teaching 103, I always loved to choose accounting. So because you find intelligent students there, so it's always beautiful teaching your group. Okay, so I'm not surprised. All right, so let's go on. Okay, so now this is the rule here. Okay, so that's exactly what I used. The only thing is that I went the opposite direction. So if you have a to the power of n minus m is the same thing as a to the power of n all over a to the power of m. Okay, so let's go on. So that's how I got this, and that is equal to 12. Now what we are going to do is we will substitute so that it will look nice. So let our 2 to the power of k be equal to, let's give it a name. Let us call it x. Okay, so if we call it x, then the whole of this now will become x plus the one on top here will also be x all over 2 raised to the power of 1 is 2. And that is equal to 12. So what do we do there? So we will try to now clear the fraction. How do you clear the fraction? Multiply through by 2. Multiply everything here by 2. So if we multiply this by 2, we'll have 2x. If we multiply here by 2, why are we multiplying by 2? Because we want to clear this fraction. So 2 will cancel this 2. And then we multiply this side by 2. You are multiplying everything. Because in mathematics, you must do whatever you do on the right, you must do it on the left. Okay, so what do we have now? So we are going to get 2x plus, the only thing left here now is x equal to 12 times 2 is 24. Okay, so that is going to give us 2x plus x is equal to 3x, and that's equal to 24. So if we divide both sides by 3, so we will get that our x alone is equal to 8. Now, but this is not our answer. Remember, we are looking for k, and we said let our k be equal to, let 2 raised to the power of k be equal to x. So let's bring that down again. So that means our x will replace it with 2 raised to the power k. So we have 2 raised to the power k is equal to 8. Then we know that 8 is the same thing as 2 raised to the power 3. So that means, okay, let me write that down here. So that means our 2 raised to the power k will be equal to 2 raised to the power 3. So why did we do like this? So that when you have equal bases, then you can also state that the powers are equal. So automatically, if we remove this, we will have that our k is equal to 3. Okay, so once again, Alex, thank you. So this is correct. K equal to 3 is correct. So if you come here, that is option C. Option C. Okay, so and like I said, Naimeka, that's good. So like I said, you people are going to do the second one. So I'm going to leave for some minutes, then you will do it. Let me write the options, even though I don't want you to do tumbom. Make sure you are doing it. Okay, so option A, I think is the same option. Yes. Okay, not very much the same. Let me write. So option A is half. Option B is 4. Option C is 30. Option D is 2. Okay, so go ahead. Yeah, Cynthia has 2. Ifoma has 2. Amanda has 2. Beautiful. Okay, who else? So it's fine. I'm not in a hurry. If I move the red stuff, I might not understand what is. Okay, yeah, you are right. If you move that red stuff, you'll probably miss some things. Yeah, that's okay. So, but you are following now. I think you are on the same page with me now. Okay, so, all right. Who else? We just have 3 answers. Okay. And you can check if this answer is correct. Let's run a quick check with the answers that Cynthia, Ify, and Amanda gave to us. Let's substitute 2 into this equation and see if we get 12. If we put our y as 2, 3 raised to power 2 plus, then 3 raised to power of 2 minus 1 is 1. So that is 9 plus 3. Of course, you can see this is equal to 12. So even without solving, you can see that 2 is correct. Very much correct. So, but if you follow the same steps I used here, you will get that answer as 2. And as my own training for you, I'm not going to be doing it. So I want every other person to also do the same and make sure you have gotten that too. Okay, so let's go to the next one. All right, so the next question is number 5. Number 5 is not a big deal also. You have given that the root of 72 minus the root of x plus the root of 8 is equal to 3 root of 2. Okay, so they said we should find x. Okay, so this one is from surds. The previous one we did is from indices. The first one we did was from sequence and series. So this one now is from surds. Alright, so what do you think? What can we do? Very simple. You can take your root x to the other side and bring 3 root 2 to this side, and that will help you finish what you want. Okay, so let's quickly do that. So bring down this one, root 72, then plus root 8. Then if this one comes over, it becomes minus 3 root 2 is now equal to, if we move over minus root x to this side, it will become plus. So you just have plus root x. I hope everybody is following. Okay, sorry. I didn't know some other people responded. Chigozrim, Ami also responded. Naimeka, Sam, Dan, Antonia, Chooks. Julian says he does not understand. Is this Julian is supposed to be a male? I think so, yes. Which one? Is it the one I did or the one I said you should do? Julian, help us. Let's know where you are. Is it the one I did or the one I said you should do? You got 50. Alex, for which one? Okay, that's for number 5. Where are the options? Okay, let's write the options for number 5. A is 128, B is 72, C is 50, and D is 32. Okay, we are going to check. Antonia has K as 2, yes. Is it K that I asked you to solve there or Y? Is Y or not K? But it's okay if you want to call your own K, no problem. Alright. Julian, since you're not responding, let's go on. Okay, so it's okay if you can give me answers for number 5. I've received 2 already, or 3. Naimeka, or 4. Okay, sorry, 3. Alex has 50, Naimeka 50, and Amanda. Okay, so let's also be looking at it together while I am seeing some solution. Okay, Julian says both of them. Okay, how do I explain it so that you will get it? Okay, so first of all, we apply the law of indices here. Okay, we apply the law of indices. We asked ourselves, what does it mean for you to have 2 raised to the power of k minus 1? So while I'm explaining to Julian, you can be doing number 5, the rest of us. Okay, so, and then we interpreted it. In maths, you just try to interpret what you're given. Maybe it will help you get what you want. Okay, so we interpreted it by saying that by the rule of indices, if I have anything, let's say x to the power of a minus b, that it means x power a all over the same x power b. That's only what we did here. And then we multiplied through by 2. But before that, we said let's call this 2 raised to power k. Let's give it a name. We said let's call it x. And so we replaced here with x and replaced here with x. You can actually be doing that here. If you want, you can do all of that here. So we replaced here with x and replaced here with x. Then we now said, let me remove this. Then we said that, okay, from here, remember that this one is 2 to the power of 1 is also 2. Okay, so we said, let's clear the fraction. And to clear the fraction, all you need to do is to multiply through by this denominator. But if there were 2 denominators, you will use LCM. So if you multiply everything here by 2, if you multiply x by 2, you get 2x. If you multiply this one by 2, the 2 will cancel the 2 below. So you just have plus x equal to, if you multiply 12 by 2, you get 24. That's what we did. And when you add 2x plus x, you get 3x equal to 24. If you divide both sides by 3, you get that x is 8. So we now brought back that 8 here. So if you remove this x and put 8, then your 2 raised to power k will be 8. So change 8 to base 2. That will give you 2 to the power of 3. Okay. So, and we know that once the bases are the same, therefore the powers are the same. That's how we got 3. I hope that you got it now. So please do the other one. So let's go on. So for number 5, I've gotten plenty 50, 50, 50. Do we need to solve it together? Okay, let's do that. So from here, Okay, I'm already solving it. Okay, Gosrim has 50 also. So from here now, we'll just add what we have. Now, you know that you cannot add sorts of, what do you call it, different, what do you call it now? Different irrational parts. Sorry about that. So we need to simplify. And to simplify this one, you are going to get 36 times 2. Then this one will give you 4 times 2. And then you already have this one as 2. That's 3 root 2. Everything is equal to root x. So we will now take the square root of the perfect squares. The square root of 36 is 6. So it will come out of the root. The square root of 4 is 2. It will come out of the root. Then minus 3 root 2 equal to root x. Now we can now add. So 6 root 2 plus 2 root 2 will give us 8 root 2. Then 8 minus 3 will give us 5 root 2. And you are done. That's equal to x. So you need to now bring back, because you can see that your root, your x is under the root. So you need to bring this 5 into the root also. And in doing that, remember when this 5 comes into the root, you need to square it. Because before this 6 came out of the root, you took a square root of something. So if you want to bring in the 5, you will need to square it. And of course, if you square 5, you will get 25. So you have 25, and it will multiply the existing 2. And that is equal to root x. So that's all you need to do. So which will give you root of 25 times 2 is 50, and that is root x. So your square root will cancel square root. Therefore, our x is equal to 50. Okay, 50 is correct. Hooray. Everyone. So that's very correct. Okay, so let's move on. Okay, so let's move on to the next one. Number 6. Okay, so I think number 6 will be very important for us. We have the word percentage. Do you have answers for number 6? Let me see your responses. Number 6, find the number of ways the letters of the word percentage can be arranged if the vowels must be together. So if the vowels must be together, we should find the number of arrangements that we can get from the word percentage. Are you still with me? Please, here is a little bit quiet. If you are with me, yes, I can see somebody giving emoji. If you are with me, please give emoji. Touch something. Let me know you are still here. Okay. Yeah, Alex says 7 factorial. Is 7 factorial in the options? Okay, yes, option A. Meanwhile, let's write the options here. Option A is 7 factorial. Option B is 7 factorial times 4 factorial all over 3 factorial. Option C is 8 factorial times 4 factorial all over, 3 factorial. Then option D is, Option D is 4 times 8 factorial. Okay, so Alex says he has 7 factorial. Madoka says B. Okay, you can use the options now. Antonia says no, sir. Okay, the no, I didn't know where the no is coming from. Okay, but I think I asked if you are following me. Now, I've not solved yet, so just don't worry, I'm solving it now. Okay, so let's go. So, how many arrangements are you going to get from this, from the letters of this word, if the vowels are tied together? See how you are going to solve it. Solution, follow me. Please, I'm going to be asking for, I think the second paper says if the consonants are tied together. So you are going to do that one. So pay attention here. So what do you do? Now let us separate the consonant from the vowels. So let's bring out the consonants first. P is a consonant. R is a consonant. C, N, T, and G. Okay, so these are the consonants. Now let's bring out the vowels. E is a vowel. Another E is a vowel. Okay, let me use a different color to write the second E. Okay, the second E is a vowel. A is a vowel. And then finally, or let me use blue here, there is a third E there, another vowel. So, first of all, how many letters do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 letters in all. Let's count this and be sure it's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this also 10. Okay, so let's go. So what is the question saying? Is telling us the condition you're giving is that your vowels must be together. So let's tie our vowels together. Let's use this rectangle to tie our vowels together. Okay. So what this question is saying is that, assuming I want to rearrange, I must keep all of this to be together. That's the whole vowel should be together at any point. Let me show you another kind of arrangement. This is one arrangement. Another arrangement you can have can be P, R, C, N, T, G. Okay, sorry. Instead of having G here, I can have E, E, A, E, then G will come last. So this is another arrangement. So the only thing they are saying is that any point where your vowels are, all of them must be together. Okay, now let's go ahead and see how to solve it. Very simple. When it comes to getting the number of arrangements you can get from a word, see how we go about it. Let me use the letter or the word God. So the number of arrangements you get from God is just count the number of letters and take the factorial. And if there is any repetition, you divide by that. But in this case, there is no repetition. So your answer is 3 factorial. So if I have something like good, what's going to be the answer? That's going to be 1, 2, 3, 4. So I'll have 4 factorial all over. There is a repetition. Letter O repeated. So I'll count the number of repetitions, which is 2. So I will divide by 2 factorial. Do you get that? Yes. So that's how to go about it. Okay. So if I have something like, let me say, eagle. Okay. So that is going to be 1, 2, 3, 4, 5. So I will have 5 factorial all over. E repeated 2 times. So that will be 2 factorials. Now, which other one? Okay, there are many of them. Okay, so now let's come back to the one we are giving. Now here, you are going to treat these vowels that you tied together as one word. Please follow me. So as one letter, sorry. So you are going to count 1, 2, 3, 4, 5, 6. Then the whole of this is going to be 1 letter. So that's 7. So you are going to have 7 factorial. Then you ask yourself, out of this 7, is there any repetition? No alphabet repeated here. So I'm not going to divide by anything. But that's not where you will stop. Now you are going to have times. You will now come into this one that you tied together. You will also check for the number of arrangements you are going to get there, because they are also not the same. So you are going to have some rearrangements also. So what are you going to do? You will also count the number of alphabets here, because initially you counted it as 1. So you are going to also now treat it differently. Then in treating it, you are going to multiply. Okay, my marker is, what happened? Sorry, just a minute, my marker went off. Let me know why. Okay, thank you, it's back. All right, so now you are going to treat this one as a different word. So you count it 1, 2, 3, 4. So you are going to have times 4 factorial all over. Now you will check for repetition. There is a repetition here, and the repetition you have here is 1, 2, 3. So that's E repeated 3 times. So that will be all over 3 factorials. Are you with me? Just follow me when I am done. If there is any question, you will ask. So this is going to be your answer. So you will just simplify this. Okay. Now, how you are going to be sure that this is, or you have understood it, is that by the time we will do the consonants. But even before going to do the consonant, let's use another word to try it before I come back and finish it. So see what we are saying. Let's assume you have ego. I just removed ego. Okay. And they're asking you to get the number of arrangements if the vowels are going to be together. Let's arrange it again. You are going to have G is a consonant, L is a consonant, then you have E, A, E. So see what you are going to do. You will tie your E, A, E together because they are the vowels. So your number of arrangements will be 1, 2, the whole of this will be 1. So you have 3. So you have 3 factorials times, then you will now treat this one differently, which is 1, 2, 3 as well. So 3 factorials all over the repetition. Repetition here is 2. Are you following what I'm saying? Did you understand what I just explained here before we finish the solution? Please let me see your response. Let me have your response. Let me get your response. Did you understand the explanation using these 2 examples before we finish the solution? All right. Alex is there. Who else is following? We are now. I remember when I taught your current 001. So we took time. I gave them different words and they were solving it. So that's what we are going to do today. In case tomorrow the question changes from percentage to another word, you should be able to frame it. So let's now finish this. Then I'll start giving you words. So this is now going to be 7 factorial times. You know that this one is going to be 4 times 3 factorial all over 3 factorial. So this will cancel this. So your final answer is 4 times 7 factorial, or 7 factorial times 4. Okay, and you can see, do we have that anywhere? Okay. Woo. So it's not in the option. So you are going to take nota assuming this comes out. So this is the only one that comes close to it. All right, so that's the one that came close to it. So, and it is not there. So please solve the one that included consonants. Okay, we are going to look at that now. Okay, so now the one that said, that's the other question that says, assuming the consonants are the ones that are together, how do you do that? We are going to use this same arrangement now. Let me clean here. Okay, so let me use eagle, so that I want you to do this one, so that let me be sure you got it. Okay, somebody said I made a mistake. Where? What did I omit anything? Okay, no, check, where is the mistake? Let me see. Percentage, you have E. What's the mistake? Okay, yeah, option B, sorry. Okay, option B is the same thing. That's actually what we got. Okay, somebody is saying option B. Yes, option B is correct. Yes, if you multiply this, you will get 7 factorial times 4 factorial all over 3 factorial. Yes, is correct. Thank you. There is no mistake anywhere. Okay. Yeah, Amanda, thank you. Chidimma, yes, thank you. B is correct. Very much correct. Okay. And Godson already said that. Ami already said that. Cynthia said that. Okay. Yeah. That's great. Beautiful. Okay. Innocent. Check what you have. What do you call it? 3 factorial is correct. It's supposed to be where it is. But meanwhile, I hope you know that this and this are the same. Please, of course you know that they are the same. I only simplified. They are the same, okay? Okay, so they are the same. Okay, so let's go on. Okay, so someone said we should do for consonant. So, and I'm going to use eagle so that you will do the consonant for the percentage. Okay, so let's go there. So for that, I'm going to also gather them. So consonants GL, then the vowels A, E, E. Okay, so let me use my yellow marker to tie this one together. So now let's go. That's going to be, so the number of arrangements is going to be 1, 2, 3, 4. So you are going to have, sir, are we not going to multiply? Of course you can multiply it, but we are going to solve according to the options you have. So we didn't even need to get to 4 times 7 factorial. That's what we are saying. You should just stop here. That's your answer. Julian, I'm responding to you. But you can multiply depending on the options you have. Okay, so let's go back. So this is 1, 2, 3, 4. So you have 4 factorials all over. You can see there are repetitions. So E repeated 2 times. So that's going to be all over 2 factorial. Then times, you now come back to the one you tied together. The one you tied together, there are 2 alphabets there. So which is 2 factorial. And nothing repeated. So you are not going to divide by anything. So your answer, this will cancel this. Your answer will be 4 factorial. Alright. So I hope you got that one. So please, for the word percentage, I think the answer can be B. Yes, we already corrected that. The answer is B. Yes, B is correct. Okay, so let's go back. Everybody, for the consonant of percentage, let me write it again here. So we are now looking for the number of arrangements for percentage if consonants are to be together. Let me write out the options. I meant a question that said consonants are together and vowels are together. That's also perfect. In fact, you are the ones that is going to do it. Okay, that's what the question here said. If the consonants must be together and vowels must be together. Okay, I'm going to do that one myself. But now I want you people to do for me when consonants are together alone. Don't put vowels also. Just do for consonants alone. Do it for me now. Let me see your answers. Everyone. Alex, I'm going to do this one now together. That's the one in the other paper where you have different options. I will bring that one up later on. But do this one for me when consonants are together. When consonants are together. Everybody, I'm waiting. If you are doing it, let me see your thumbs up so that I know I'm waiting for you. Okay? You can just touch something. Let me be sure I'm waiting for you. Zoku. All right, I'm already getting responses. That's beautiful. Cynthia, Football Chronicles. That's great. I think this is a channel. If it's a channel, let me know. You have my phone number. Chat me with your link. I will subscribe to your channel. I like to support my students. I see that some of you have channels. Uh, if you're actively creating content, you can chat me up later. I will subscribe to your channel. Okay. All right. Okay. Beautiful. Alex, Dan, Agoziem, Football Channel changed its own again. Did you change it? Yeah. Okay. Favor, Ikechukwu, Shedima Amos. All right. Ngwano. Okay, yeah, you are welcome. Football Chronicles, you're welcome. Just let me know. At least 5 subscribers from me. 5. I will give you. Okay, at least. It may be more than that, Seth. Okay, so let's go on. So let's check and see what we have. Let's check and see. Okay, so if you bring, in fact, let me go up again. Let me still use this my own. All right, instead of writing that again. Okay, so if you use this one now, we have separated the consonants. Let me remove here. Okay, let's use the smaller. Okay, all right. Okay, so now in this case, it is the consonants that we want to tie together. So let's do that. I think my marker has passed. Okay, this is where consonant stopped. Okay, so the whole of this is now one alphabet. Okay, so we are going to count now. So this is 1, 2, 3, 4, 5. So we have 5 factorials all over. There are repetitions. E repeated 3 times, so we have 3 factorial. Then multiplied by, we will now work on the consonants, which are 7. 1, 2, 3, 4, 5, 6. Okay, consonants are 6, sorry, not 7. So you have multiplied by 6 factorial. So that should give you 5 factorial times 6 factorial all over 3 factorial. I'm aware that some of you reduced your own. Okay. Some of you that simplified your own. If you simplify it, you can get something like 20 times 6 factorial. Okay, so first of all, let me see the people that got the first, that used this first form. All right. Cynthia, that's nice. Who again used it? Who again? Innocent, I didn't get this. Okay. Chukwu Antonia used that. That's beautiful. Ifoma used that. That's beautiful. Okay. Now, Godson used this one, 20 times 6 factorial. That's beautiful. Who else? Chiagoziem used that. That's beautiful. Okay. Now, some people may also simplify from 6. If you simplified from 6, that would be 5 factorial times 6 times 5 times 4. 6 times 5 is 30 times 4 is 120. So you should have 120 times 5 factorial. Did anybody get that? No. Okay. So, all right. Okay, so these are the different forms it can have. Either this, or this one. Okay, or you can choose to open the whole bracket, as in the whole factorials. Alex, you got 5 factorial over 4. Sorry, times 4 factorial. I don't know how that came. How you got that? Okay. Check again. Maybe there's a mistake somewhere. All right. Praise, you have 5 factorial times 6 factorial. Check again if there is a mix-up somewhere. There should be all over 3, because there is a repetition of E. E repeated 3 times. So there should be that. Okay, yeah. Broke, how do I pronounce that? That is correct. Then Julian, that is correct. I think there's one I said up that I didn't know what was written. I think that's actually correct. Maybe that's what you rewrote now. Okay, 4 factorial over 3 factorial times 6 factorial. No, that I'm not sure is correct. Okay, so that is very beautiful. So did we follow what I explained? If we followed, okay, Esther says she doesn't understand. I want you to get the idea. Now, the idea is that by the time you tie this one together, they will form one word. Sorry, one alphabet. Then you will now count the remaining. So this is one alphabet plus this 4. That's 5 factorial. Now, but remember that when you had good, for instance, when you had good, for instance, you counted, which is 4 factorial, but you divided by the factorial of the number of repetition, which is 2, So you had over 2 factorial. That's exactly what we are doing here. So in this case, when you counted, you have 5, but you will now divide by the number of repetition, which is 3. So that's how we got 3 factorial. Now, you are supposed to stop here, but there is something you tied together. You should also check the number of arrangements those ones will have. Okay? Yes, we said consonants only. Yes. So how did you get 6? From which one? Okay, that's what I'm explaining now. After you've gotten the whole factorial, the whole arrangement, after tying this one together, you will get 5 all over 3 factorial. Now you will still arrange the ones you tied. You won't forget them, because this one you tied together, you can choose to keep R first before P. You can choose to keep G first before all of them. So those ones also have their own arrangement. So you also come and arrange them. Now whatever you get from their own arrangement, you will multiply it with the general arrangement. Now the general arrangement gave us 5 factorial all over 3. So the arrangement of the one you tied together will now be, you count the number, which is 6. And you still ask yourself, is there any repetition amongst those ones you tied together? And there is no repetition. So you just stop there. So that's how we got that 6 factorial. I hope my explanation is better now. Esther Chukwemeka, I hope you got me now. Prosper, how do we solve when they must be together? That's actually what we are doing. Okay, that's what we are doing. Okay. Yes, there is no repetition in the consonant, so you can't divide by anything. The repetition is telling you what to divide with, but since there is no repetition, you cannot divide by anything. But there is repetition in these other vowels, and they are part of the whole. That's why you divided by 3. When you're considering everything, this one is 1. There's no repetition here. But here you have 4 letters, which is added to this one to make it 5. So, and there is repetition among them, which is 1, 2, and 3. I hope you have gotten that. Okay. All right. They must not be together. How do you solve when? Okay. When they must not be together. All right. That's even where we are supposed to start. In fact, let's now come down here and do it. Okay, so let's assume that they didn't tell you anything should be together. Are you getting me? When anything should not be together, all you need to do is to count everything. And that's 11. So you have 11 factorial all over. You now count repetition. So E, and E repeated 3 times. That's your answer. That's your answer. Prosper, I hope you got my response. This is your answer. Assuming nothing should be together, you are just asked to get the number of arrangements when you have the percentage. So you just treat it as one word. So then then you count the number of alphabets, which is 11, divided by 3 factorial. Where did we get the 3? The repetition of E. E repeated 3 times. So that will give you over 3. I don't get where the 10 is coming from. Where is the 10 coming from? Is it for the other question? Okay, is it 10? Okay, 10. See me now, I'm saying 11. Okay, oh, thank you. It's 10, sorry. 10 factorial all over 3 factorial. Oh, thank you very much. Thank you. All right, thank you. Okay. All right. Hey, Prosper. My God. What's your question exactly? No, sir, I meant when vowels must be together. Must not be together. Okay. If the vowels must not, of course, in the one we treated above, the vowels are not together. It's only the consonants that are together. So the vowels can be anywhere. Don't mind the way I arranged it. They can be anywhere. So, but it is the consonant. That's why I tied it together. Yeah, Antonia, thank you. Yeah, Tony, thank you. Yeah, I saw that correction. Okay, so now let's go over to the last part. That's the other paper where both vowels should be together and consonants should also be together. So when the two of them should be together, what are you going to have? So vowels together, consonants together. Okay, Jacinta says, what if the consonants had repetition? Then you will check the number of repetition and divide by the factorial. You check the number of repetition and divide by the factorial. Yeah, Ugumba, thank you. Is 10 factorial. Thank you. Yeah. Okay. So, Jacinta, did you get what I said? You check the number of repetitions and divide. Okay, don't worry. I'm going to give you a word that will capture that. Okay, so let's come back to this one. All right. So here, that's the second paper. In fact, let me even allow you people to try it. Can you try it? When the consonants are together and the vowels are together. Let me see what you can attempt. Try it. Let's see. Sir, please solve this one. 8 factorial all over 8 factorial over 5 factorial is equal to 8 times 7 times 6 times 5 factorial. Once you reach where you have 5, you stop there and divide. Why did I stop? Because 5 factorial is in the denominator. So 2 of them will cancel out. So your answer will be 8 times 7 times 5. So use your calculator and check 8 times 7 times 6. Sorry, that's your answer. This question is for who? Chinemelum Evangeline. Okay, Agozem, the answer you wrote now, is it for the question I asked? Vowels together, consonants together. Is it? Let me know. Okay. Confidence says I should use an example where there is a repetition in consonants. Can we finish this one first? Then we do that one. Please, let's finish this one when consonants are together, when vowels are together, so that I will give that example. Let me be getting the word. Okay. Yeah, there are plenty words like that. For instance, mathematics. Mathematics. This is an example. We are going to look at it later. Confidence. And who again asked that question? Jacinta asked the question. So you can see mathematics. Alright, so we use it. Then let me remove it. Let's first of all finish the one we are doing. Chinemelum, I hope you have gotten this one that you asked. So I want to clean it. Okay? So I'm expecting answers for this. Vowels together, consonants together. Alright, I've received answers from Chiagozie, from Alex, from Ify, from Innocent, from Football. Football, what's your name? Please write your name for me. Let me be calling you by your name. Okay, from Antonia, from Cynthia, and so on. Okay, so let's run it together. Solution. Okay, so what are we going to do? Let's still separate them. P, R, C, N, T, G. Okay, this one should be together. Alright, then consonant vowels E, E, A, E. Okay, this one should also be together. So you can see I tied to 2 of them. Alright. Okay, Matthew. Alright, so I hope I don't forget. Okay, so I've tied the 2 of them. So how many letters do we have? In general, we have only 2 letters. That's the consonants tied together, the vowels tied together. So you have 2 factorials. Any repetition? No, because they are tied together. 2 of them are tied together. They are just one alphabet. So you are not seeing any repetition. Now, but you will still treat them, what you tied together, differently. So now you have times. So let's treat the one we tied on consonants. That's 6 factorials. No repetition. So we are done with that. Let's treat the one we tied on vowels. They are 4. So 4 factorial. All over, there is a repetition of 3. So you have all over 3 factorials. So this is going to be 2 factorial times 6 factorials times 4 factorials all over 3 factorials. See, I need to clap for some of you. You are doing well. Like I said, this is why I love to teach seriously, whenever I'm teaching and students are following, it used to give me fuel. Like, I want to continue teaching even when I'm tired. Okay, so this is beautiful. Chibuzo, this is correct. Lady, this is correct. Please, going forward, don't simplify. Let all of us be having the same answer. Don't simplify. Don't simplify. Just leave your answer the way it is, like this one. Just leave it like this, okay? So that I will be following everybody at once. So don't simplify, all right? Chibuzo, that's correct. Lady, that's correct. Daniel, that's correct. Julian, you have simplified. So I don't know which one. So write it again for me. I'm blessed, correct. Cynthia, correct. Antonia, correct. Chidima, I think you simplified. I don't know. Matthew, I think you simplified. Innocent, that's correct. Ifoma, that's correct. Alex, that's, oh, seriously, I am so happy to see these responses. I clap for you again. I clap for you again. This is, let me give you love emojis to all of you. This is so beautiful. I love this. I love this. Steph, that's beautiful. That's beautiful. Seriously. So if you can arrange this one, there is no word we give you that you cannot arrange. There is no word we give you that you cannot arrange. So that's why if you ask your O1, he will tell you, I gave them strong words. In fact, this particular question, I was the one who gave it that particular year. I was the one who set this question because it was me and Mr. Peter that taught that year. So two of us brought question. I was the one who brought this particular question. All right. So it's very beautiful. Okay, so let's come back to mathematics. You will see all of you will do mathematics now with very easy approach. First of all, I'm going to be giving you what to do. Follow me. Now, I'm going to be giving you what to do. The first one is arrange it without any togetherness. Just give me the number of arrangements. Number of arrangements. I don't want nothing is together for now. So just get the number of arrangements. I'm waiting. Yes, I love that emoji, Cynthia. Yes, that's the way it goes. Okay, I'm waiting. Number one, no arrangement. As you're getting the writing your answer, I'll be seeing it. Then number two, let me wait for number one first. Sir, what if the consonant has repetition and vowels also have? That's exactly the question I've given you now. There is repetition in consonant, there is repetition in vowel. First of all, do for me when there is no togetherness. Do that one first. Let me see what you've got. Your answer. Your answer. If there is repetition in consonants and in vowel, all you will do is just, let's come back here. So assuming that there is repetition here, let me take for instance that C here repeated as N. Let's assume that N repeated there. So that's going to still be 6. And then all over, you will now count that N that repeated, which is 2 factorial. That's all. Do you get the idea? It's nothing difficult at all. At all. That's just it. If there's repetition, you bring repetition under the consonant that repeated. You bring repetition under the vowels that repeated. That's just it. That's just it. Did you get that? I'm blessed because you are going to do it now in mathematics. Oh, beautiful. Great. Great. I'm seeing beautiful answers. They are all correct. Daniel, you are correct. Rita, your answer, I think it is for percentage. That's very correct. Okay. Daniel, you're correct. Cynthia, Antonia. I'm blessed. You're writing 10. Is it 10? Mathematics is 11. Okay. Chinonye, you are correct. Ifoma, you're correct. Gozrim, you're correct. Julian, you're correct. Oh, beautiful. Amanda, I said let's not simplify. Let's not simplify so that the answers will look alike. Let's not simplify, but that's beautiful. I think you simplified, and I think that's correct. Don't remove it. Just give me what you got earlier. All right. So that's correct. 11 factorial all over m repeated 2 times. That's 2. A repeated 2 times. That's 2. And then t repeated 2 times. That's also 2. I think that's the only repetition. This is very correct. Thank you, everyone. Thank you, everyone. Amanda, thank you for writing that other one. This is beautiful. Okay, now let's do when consonants are together. When consonants are together. When consonants are together. Quickly, everybody. When consonants are together. By now, you should stop giving answers for the first one. We have moved on from there. Lady, that's beautiful. Lady, you should tell me your name, so that I will be calling you by that name. Matthew, at least I now know his name. Chibuzo, that's correct. Okay. So let's do when consonants are together. While they are doing it, I'll be doing my own too. Okay. Precious, you are here. Welcome. Okay. So we are doing when consonants are together. What's it going to be? Okay, when consonants are together, don't simplify. Don't simplify. Just write the answer. Okay, praise. I think that is for the first one. That's correct. That's correct. Okay. I'm waiting for you. I'm not away. I'm here with you. Okay. Okay. We are doing when consonants are together. Please ensure to give a thumbs up to this video. Please. Okay. Okay, I'm seeing responses already. I'm doing my own so that I will be checking what you have. Okay. Okay, so let me see. Okay, let me see the answers. You have, okay, I think it started from Ifoma. Okay, Ifoma, we said when consonants are together only. When consonants are together only. Don't simplify. When consonants are together only. Don't simplify. Okay, let me look at what we have. Okay, Alex, okay. Innocent, Alex, okay. Alex has removed his own. Don't simplify. When consonants are together only, don't simplify. If I might check that response again, check it again. Only consonants, only consonants. I think Innocent, check your own also. Julian, okay. Antonia, okay. Dan, check your own. Please don't simplify so that we'll be having the same answer. Agozim, okay. Gozrim, check your own again. Alex, that 4 factorial, where is it coming from? I have issue with that 4. Don't simplify. Okay, who again? Chibuzo, beautiful. Matthew, the 4. I don't know where it's coming from. Cynthia, beautiful. Precious, beautiful. Ugumba, your factorial is not complete. I hope you know that 2 factorial times 2 factorial times 2 factorial is not 6 factorial. Chukuma, I hope that's not where you're getting that 6. It is not 6 factorial, please. Okay, so let's look at that one together. First of all, you need to separate them. You have M, T, H, then M, then T, then C and S. You know that I is a consonant. I hope you know. Sorry, it's a vowel. Okay, so let's now bring out the vowels. A, E, A, I. Okay, so Amanda, your that 4 factorial, I have issue with it. And your denominator should be 3. Ugumba, that's correct. Lady, you didn't tell me your name again. That's correct. Who else? Alex, that's beautiful. Thank you. Chukuma, I'm still talking about that 6 factorial that you have in the denominator. Are you sure that that 6 is not from 2 times 2 times 2? It is not 6 factorial. 2 factorial times 2 factorial times 2 is not equal to 6 factorial. Please take note of that. Okay, so I've seen many correct answers. So let's do it together. Please, now this is what we have. But it is only consonant that I said should be together. So that's the only one I'm going to tie. So if I tie it, you will have the whole of this will be one alphabet, then 2, 3, 4, 5. So that's going to be 5 factorial all over. There is repetition in this 5 that we just counted. And the repetition is A. A repeated 2 times. So you divide by 2 factorial. Then multiplied by, oh my God, this is so beautiful. I love what I'm seeing here. All right, let me give you people emojis first before we continue. Okay, so then you will now come and arrange the ones you tied. And here the ones we tied are 7 in number. So we have 7 factorial all over. Then you look for repetition. So M repeated 2 times, that's 2 factorial. Then T repeated 2 times, that's also 2 factorial. So your answer is 5 factorial times 7 factorial all over 2 factorial, 2 factorial, 2 factorial. And that is your answer. And I have many of them here. I have many of them here. Yeah, Ugumba got that. Chukuma got that. Alex got that. Who else? Yeah, Cynthia got that. Chidima got that. Matthew, did you redo this? I didn't know where you got 4 factorial. Chibuzo got that. Innocent, did you redo this? And so on. Gosrim, your own has only 2 factorials. 2 of it. It should be 3. Okay, it should be 3. Okay, so let me get back. I saw where Nemelum is saying, I don't get. Is it for which one? Remember we... Okay, hello everyone. I think I'm going to take a break now because they said my device is heated up. I'm still in number 6, Jesus Christ, Jesus Christ. Okay, please, let's take just 30 minutes break. 30 minutes break by 23 minutes break. By 9:25, we should start joining. Highest 9:30, we will start. Let's just cool off a little bit. But be doing this. Let me also add for only consonants. Please, sorry, for only vowels. When vowels are tied together, do that also, and then show me when we return. And so that immediately we return, we will go down to other ones and finish. So you permit me, we'll finish the whole of the questions we have before doing extra examples. I hope that is better. Okay, please, let's take just a little break. Oh, Alex, I'm very sorry, and you don't have power bank. Oh God, we are going to miss you on the chat, on the group. But let's take a break. Maybe you can find a place to power it a little bit. We'll be back in 20 minutes time. All right, see you, friends. Have a very good break while we come back. All right, bye for now.